All right, thank you all again for joining. Our next panel on rate considerations for EV charging will begin. And so I'd like to welcome our panelists, Paul Allen from MJ Bradley, Phil Jones for the Alliance for Transportation Electrification, and Chris Budzynski from Exelon. We're excited to have these folks join us. They're going to share a little bit of information about both benefits to the system of electric vehicle charging, as well as providing an overview of some of the rate options with a focus on the demand charges. And then we'll hear a little bit from Exelon about what's happening in their service territory. And so I'm going to kick it over to Paul Allen to get us started. And Paul, I will pull up your slides now. Go ahead.
Great. Thanks, Cassie. Well, thanks, everyone. It's a pleasure to be here, and very nice to be sharing some time and some video screens with Phil and Chris. I should quickly probably explain who MJ Bradley and Associates is. We're now part of the ERM Group, which is an international consultancy that serves clients across all sectors of the economy. MJ Bradley and Associates work has been grounded for the past 25 years in close collaboration with and support for many of the utilities and independent power producers in the U.S. electric and gas sector, as well as 20 plus years of working with transportation companies, OEMs, transit authorities, and ports. A lot of that work has been focused on heavy engines, including locomotives and diesel trucks and buses, but also medium and heavy duty vehicles for delivery services and freight, as well as passenger vehicles. In virtually all of the work that we do, there's a policy and a regulatory analysis component with a very strong focus on climate and clean air policy. Matched, we hope, with insights into energy markets and transportation markets. A lot of our work is focused on federal policy, particularly Clean Air Act matters and the current debate around climate provisions. And we've had the great good fortune to work with a number of electric companies that take very constructive and progressive positions on climate. I'm going to share a couple of slides to address what a major shift toward EVs could look like as seen through a benefit cost lens. And I want first to thank my colleagues, particularly Dana Lowell and Dave Siemens, who did really the lion's share of the framework and modeling analysis that I'm going to share just a little bit of with you right now. So Cassie, if we could go to the next slide, please. We all know that, and we were just hearing in the previous discussion about the many tectonic shifts that are driving us toward a very rapid evolution of or convergence of the electricity sector with the transportation sector. It's exciting times. It's deliciously complicated, but it's also this is the right time to be asking why should society invest in EVs, who will benefit, and how. And so we developed an analytical framework to estimate the net benefits of EVs at state and regional levels. This accounts for benefits to electricity customers from reduced electricity rates. That's the thing I'm going to talk about mainly. And then what are the benefits to EV owners? Really, that's a total cost of ownership story. And then to society. In this framework, in this modeling, we look at greenhouse gas reductions. We do not look at the potential benefits from the reduction of criteria pollutants, from reductions in ozone or PM, or the public health benefits that would accrue from that. We think that's actually very important. And in some of our other work, we have collaborated with other agencies and individual companies, as well as with environmental justice organizations, to better understand particularly what transitioning medium and heavy duty vehicles and transit buses would mean for underserved and overprivileged, underserved and overburdened communities. This is not that. What we did do is we looked at multiple penetration and charging scenarios for light duty vehicles, which includes passenger cars, sedans, light duty trucks, and SUVs. The work I'm going to be sharing with you here has been used by NGOs and utilities in Public Utility Commission proceedings related to utility investments. It's in the record in rate cases in Maryland, in Massachusetts, in New York, and elsewhere. We've completed 12, about a dozen analyses, a dozen state analyses, which is what I'll be showing you in a moment. We're actively working on several others. Cassie, I think we could go to the next slide, please. So to summarize at a very high level, to achieve a really deep level of greenhouse gas reductions, 80% reduction by 2050 from the LDV sector, would require 80 to 97% of these light duty vehicles would need to be plug-in electric vehicles by 2050. In the coming days, as the UN Conference of the Parties kicks off in Glasgow, Scotland, in a few days' time, we're going to be hearing a great deal about 80 by 50 reductions. And indeed, a number of states who are represented in this call today have established goals or targets and are making very significant commitments to try to get to that kind of level of overall greenhouse gas emissions reductions. On a statewide basis, the net benefits to society are significant under each of the EV scenarios. Across these 12 states, Arizona, Colorado, Connecticut, Florida, Illinois, Massachusetts, Maryland, Michigan, Minnesota, New Mexico, New York, and Pennsylvania, the net benefits could tally close to $450 billion, $437 billion. The magnitude of statewide net benefits is generally proportional to the state population and the size of the light duty vehicle fleet. I should say a little bit about what goes into each of these categories. So as you can see from the lighter blue bars, the greatest share of benefit accrues to the vehicle owners. And as I said earlier, that's about total cost of ownership. On the greenhouse gas reduction piece, it's important to know that we used the social cost of carbon as the metric, which in the case of these particular analyses was on the order of $42 to $45 a metric ton. So significant amounts of money. There's and then you see the darker blue bar is the benefit to utility ratepayers, and that's what I'm going to talk about next. If we can go on to the next slide, please. So when you're doing this kind of analysis, you've got to start with some sort of assumptions. In most of the cases, we used policy case assumptions to craft the different scenarios. A little different than the example I'm about to show you, but in most of the analyses, our business as usual case was really based on EIA projections of where vehicle adoption trajectories are expected to go. The first policy case that we used was based on the 8-state ZEV MOU for LDVs, which actually goes back all the way back to 2013 and was then updated a bit, but just to refresh everyone's memory, those 8 states, which included California and several others, was a commitment to get 3.3 million EVs on the road by 2025. And we just used that same trajectory out to 2050 for that case. And then the 80 by 50 case, as I said, requires really ubiquitous charging, ubiquitous EVs. The Colorado case, a little bit different in that the BAU really tied to more like what the ZEV MOU trajectory would look like, had Colorado been a signatory. It's not, but that was our base case. And then for the sort of mid-range case, we used the state's goal of 940,000 EVs by 2030. And then that also has then a modest increase in the rate of growth thereafter. And then for the high EV scenario, again, that's tied to an 80% reduction from 2005 levels by mid-century. And what you see here is that electricity sales for EV charging allow utilities to better utilize existing assets, especially for charging overnight when current demand is low generally. This results in lower utility costs per megawatt hour of delivered electricity, allowing utilities to charge lower delivery rates for all customers. This was, I think, the critical insight. And when we embarked on a lot of this work 5 or 6 years ago, it was very common, and it still is common, in fact, to get the question, a very understandable question, one that seems kind of intuitive. Wouldn't a major transition to EVs entail massive utility spending and investment, and wouldn't that drive up rates? And when we did this analysis, we took into account what would be required of additional generation energy purchases, peak capacity, transmission, and upgrades to the secondary distribution system. And we used what we believe to be conservative cost assumptions in all of those cases. The phenomenon here that I think is important and that many of you understand quite well is that the increase in net revenue, and there would be a significant increase in net revenue, in general, the way public utility commissions treat that is that electricity sales from the net revenue from increases in utility sales generally offset the allowable costs that can be passed on through higher rates. So to say that another way, this increase in net revenue has the effect of putting downward pressure on rates for all electricity customers. So that's a very positive thing. As compared to the benefits to the owners and the benefits to society at large from greenhouse gas reductions, it's relatively modest. In the Colorado example, in our calculations, it would translate to projected average electric rates could be reduced by about 3% by 2050, resulting in annual savings on the order of $42 per household annually. Not tremendous, but quite different than what I think many folks had expected would be, the opposite outcome. So we think this is, along with the fact that EVs have, in many cases, simply superior performance, that we think that the costs are going to be coming steadily downward, and in recognition of the fact that as events and announcements in recent days from Tesla and Uber and Ford Motor Company and others have indicated, there's a beginning to be an air of inevitability about this. And so to the point that was made frequently in the previous panel, beginning to plan and to deal with preparations now is quite important. I did see that there's a number of questions that are coming in the chat, and I'm not able to read all of them as they come in, but maybe we can come back to them later. But yes, this is a 3% reduction compared to what rates would otherwise have been. So I'll stop there, Cassie, and make way for Phil and Chris.
Thanks so much, Paul. And yes, please, you should feel free to respond to the questions in the chat as you'd like. And so now, though, I think we will turn it over to Phil Jones to share a little bit of information on the different options for rates to support EV charging. Phil? And Phil, if you're speaking, you're on mute.
I still do that, Cassie. I'm sorry. All these Zoom calls, and I still do it. Great to be on the panel with Chris and Paul, my colleagues. We see a lot of each other around the country, although with COVID, we haven't been on so many calls together. But at the outset, I'm just going to say true confessions. I am a policy wonk and a regulatory wonk. I love this stuff. So if I get into some details in response to your questions, sometimes some people call me that, but as I keep telling people, rate design and cost recovery for the utilities is really where the rubber meets the road on utility programs and other programs, third-party programs like Make Ready. The other thing is history is important. Let's not forget about history. I mean, there's a lot of deja vu that we can learn from, and we as Americans, I think we're pretty bad about learning from regulatory and policy issues where we did things differently in the past on railroad regulation, telecom regulation, or whatever, when air conditioners came into the system. So a lot of this stuff seems to be new, and it is a transformation, but a lot of it is not new from a utility load perspective and rate design. So first, Cassie, first slide. So ATE, I think you know who we are. We're a multi-sector trade association. We advocate for an acceleration of EV charging around the country, primarily at the state level, commissions, state energy offices, governors. About a year ago, we decided that we needed to form a task force on rate design because we were hearing so much about this. And the goal was to be more proactive. Don't play defense all the time. Not necessarily play offense, but just try to provide a better perspective on rate design, not just demand charges, to the community. The private EV charging companies obviously feel strongly about this. You'll hear about it today. A lot of their expense money with low utilization is paid to utilities for either demand charges or even volumetric charges, depending on utilization. So the context was that, be a little more proactive. I'm not going to go through all these bullets, but our paper focused both on residential rates and what we call C&I, commercial and industrial rates. Some of you may not know that there are a lot of general service or C&I rates approved by commissions that have been there for a long time. Some apply to industries like big box stores, retail. Some apply to cement, steel. Some apply to irrigation. And irrigators in the western states especially have low loads at certain times of the year. So the point is utilities have been developing rates that try to satisfy the needs of those customers for a long time. And we wanted to come up with something useful to all of you on the phone today, especially the commissions and staff and state energy offices. So next slide, please. So the goals of these principles, I'll just highlight a couple of these. When we talk about beneficial electrification, as Paul did, there are three basic benefits in our view, as Paul set forth in his quantification of those benefits. Customer benefits, the EV owner or the ratepayer of the utility obviously is one. Grid benefits, the benefits to the grid, system benefits we call them, and then of course environmental and public health benefits. So the other thing we wanted to do is be mindful, as we say in one of those bullets, of the difference between an approved rate. As I just said, we have rates that are already in effect that may satisfy the needs of folks, and what we call transitional relief that I'll talk about in a minute. Next slide, please. So we do a little bit of history here. Cassie, there we go. So for those of you who haven't been involved in a rate case at a commission, I'm just going to spend some time on this. The classic volume on this is Bonbright, John Bonbright, professor at Columbia University. And here are the four functions of rate making: capital attraction, This means that the revenue requirements have to satisfy the needs of the utility. The utility needs timely and full cost recovery. And this has been tested in many Supreme Court cases over the years. Efficiency incentive. So this is meant to be, because this is a regulated franchise or monopoly, whatever you want to call it, the utility has obviously a franchise to serve all customers in a service territory. So regulation is intended to spur good performance. The third one is demand control. This may be applicable to EV charging in the future as congestion increases with chargers and queues. The whole idea is that you have scarcity of supply and demand. And so you want to get the prices, the function to be able to send price signals to host sites and customers, so that when peak is being neared, for example, that the price is going to be higher, and et cetera. I mean, I'm really oversimplifying demand control. And then the last one is income distributive function. Commissions have a surprising amount of authority to look at these distributional issues. Even though they're economic regulators, they can get into social issues, economic development issues, and as Paul talked about, the environmental issues, the impact of transportation. So it's just important to keep all these principles in mind, and we think that you need to go back to some of these basic principles as we talk about rate design for TE. So next slide, please. I'm not going to spend a lot of time on residential rate design, other than to say that we did go through this in our paper, which is 11 pages. It's a quick read. We looked at TOU rates, dynamic pricing, and as many of you on the phone know, we can use technology, which is active to manage the load, or we can use what is called passive means, trying to change consumer behavior, which is what TOU rates do. Next slide, please. But the real focus of the paper is on the commercial rates. So this is what we hear a lot about in the state commissions. Commercial rates are really complex. Demand charges are determined by an instantaneous peak. I'm not going to get into all the methodologies today of determining peak methodologies. I would really be wonky there, and I would lose your interest on the phone, but just suffice it to say that the utility goes through an extensive exercise with the commission about what peak methodology should be used in spreading and allocating the fixed costs and the variable costs of the utility back to the rate classes. So the challenge of DC fast charging, we think, is utilization can be very low, under 5%, 3%, certainly not 10% yet, with only 2% of the light duty fleet being electric. So the result, obviously, is that these relatively high demand charges are spread across few kilowatt hours. And that creates lots of challenges for the commercial operators. Next slide, please. So what can we do about this? We came up with the idea of transitional relief. And this is pretty important for a group like ours, that is utilities, OEMs, and EVSBs. This is something that we landed on. I personally don't like the word discount or credit, subsidy, economic development. There are a lot of words and a lot of phrases that commissions and utilities have used around the country, but they all have kind of emotive reasons. When you talk about a subsidy, even though we all know in rate making that cross subsidies have been going on for years and decades, and bond right principles allow this, frankly, subsidy today, especially in the environment in DC, can get pretty emotional. And so we like the word transitional relief. And again, the goal is to get past this period of what I call the valley of death. This is a nascent market. We need to get it to a more mature place. So how do we get it there? So we basically say that some sort of transitional relief is good and necessary for this. So a few are offered here: non-demand charge CNI rates below a certain demand level. Demand limiters is another way of doing it. Non-demand charge subscription rates. PG&E is doing this. Excel is doing this, and the commission has approved those in those particular states. And rebates to offset the effect of demand charges. Next slide, please. So this is a list of various efforts around the country. Actually, I'm going to update this slide in our next version, but the economic development rate or demand charge holiday has been used by SCE and National Grid in Rhode Island. I see former Commissioner Marion Gold on the call. Marion is familiar with that for Rhode Island, and Southern California Edison has actually built a demand charge holiday into their TOU rate. So for the first 4, 5, 6 years, no demand charge, higher volumetric charges, and then when utilization increases, the demand charge comes back. So that's what SCE has done. TOU rates in Oregon, it's not just Portland General, but Pacific Core has a pretty good general service rate for a certain type of demand limiter. BG&E in Maryland, I talked about subscription rates. In Michigan, we have DTE Energy that has a DCFC targeted rate of temporarily waiving demand charge restrictions. I think it's until 2024. And then at that time, the commission can revisit. Next slide, please. So utilities are acting on this, and that's the impression I want to leave you with. It's not that, you know, we're in a stalemated position. There's still lots of debate and contention about all those mechanisms, but utilities have been acting. This is another area I wanted to talk about briefly. In some states, the utilities want to own and operate the EVSC, not just do the make ready, but actually for the more difficult use cases and on corridors and just testing out the market for the utilities to own and operate and getting that data and understanding how consumers respond to off-peak pricing. So generally, the way those prices are determined is to take a quarterly average of, quote, the market. So you would look at EVgo, Electrify America, Tesla, you know, the major providers out there, what they're charging both under their member rate, which is discounted, and their full rate, which is not discounted, and you try to come up with some sort of average. And then you would adjust that every quarter. So that's what's generally being used in those states that have utility own and operate as an option. Next slide, please. Wanted to talk a little bit, no, let's skip this one. There was discussion on resiliency. Next slide, please. I just wanted to talk about that. Line extension policy. So even though this is not rate design, we're going to be talking with Chris and I think the others about medium heavy duty. So line extension policies are really important for, I think, the medium heavy duty use cases. So remember that concept of beneficial electrification. We want the benefits going to everyone. The fleet operators, consumers, the grid, public health. So line extension policies generally outline the basis on which a utility will extend its service, overhead, or underground distribution to new loads. So the way that this is calculated is they do a calculation of the estimated minimum annual revenue from the new loads, and then they look at the costs. Next slide, please. So this can be a barrier to EV adoption or to EV charging, because sometimes these line extension policies are what we call Kayak, contribution in native construction, which is another method of getting money, getting investment dollars from the customer for a new load. Sometimes this is a barrier. So several states, Minnesota is one of them, and others have acted as well, are in the process, or they have either waived those line extension policies or come up with new ones. So this is something that we're going to have to face, especially with medium and heavy duty loads. And just let me, the last slide is a bit of a provocative one, Cassie. I'll end with that one. Just to give perspective to everybody on the phone, these are the fleet EV requirements that we may be talking about at kind of regular charging levels. So this is a model done by eTrans Energy. It's part of Duke, that looked at the various models of medium heavy duty, 50 passenger vehicles, 50 medium duty trucks, 50 transit buses, and 50 Class 8 trucks. So just look at the load, starting with 50 passenger vehicles, 360 kilowatts. And then look at 50 Class 8 trucks. This is what we call megawatt level charging for a Class 8 truck, like a Tesla Semi or a Cascadia of what Daimler is producing for their Cascadia e-trucks. You're talking about a 9 megawatt load, which is bigger than the Empire State Building. So that's the challenge we have ahead of us. So I'll leave you with that, and over to Chris.
Thank you, Phil. And we have had a number of questions in the chat, a lot from the States. And so I think we're going to hold on those until we get to the discussion portion following the presentations. And so with that, I am going to turn it over to Chris to share some insights from Exelon. Chris.
All right, Cassie, thank you very much. And sometimes going last is not a good thing, but in this case, it's a great thing because I just get to reinforce a lot of the great points that both Paul and Phil made. First and foremost, I want to thank you all for having me here today to talk about, rate design as it relates to EV infrastructure. Cassie, if you want to go to the next slide, I will just do a quick overview of Exelon's utilities. And so for those of you who are not familiar with Exelon and Exelon Utilities, Exelon is a vertically integrated energy company. Exelon Utilities is the regulated portion or the regulated half of Exelon. We serve 10 million customers across 6 jurisdictions. That includes Pennsylvania, Maryland, New Jersey, Illinois, Delaware, and DC. The utilities within Exelon do not own any generation. We are pure T&D companies. And if some of you have read the news or kept up to speed on what Exelon is doing, we're actually in the process of going through a separation where we're going to separate our utility business from our commercial or our competitive business. I think in the long run, that's going to provide both sides of the company with a lot more strategic and financial flexibility moving forward. The other thing I would like to point out on this slide is that, as you can see from a utility perspective, we are investing in the grid and in the system. It's about $27 billion through 2024. Really, those investments are meant to make our grid more reliable and more resilient, and to some degree, in preparation for distributed energy resources, and also the coming coming of the electrifying transportation. Next slide, Cassie. The one thing that I do want to communicate to folks is that, our focus on electric vehicles is really part of a broader initiative across Exelon and its utilities. Earlier this year, our utility companies announced our Path to Clean goal. What that means is that we are striving to achieve at least a 50% reduction in GHG emissions by 2030 and become net zero by 2050. Our goal right now is really focused on Scope 1 and Scope 2 emissions, but we are working to support our customers as they look to reduce their GHG emissions. And one important thing I'll point out, or one aspect I'll point out of our Path to Clean initiative, where we're going to get a significant amount of GHG reduction, is our effort to electrify our utility fleet of vehicles. Our goal right now is to electrify 30% by 2025, and then electrify 50% of that utility fleet by 2030. As I look at and think about our EV programs that we currently have today and how they support our Path to Clean initiative, we're really designing our programs to address barriers to EV adoption. So when you look at our programs, you're going to see 3 main characteristics or 3 main buckets of those programs. One is going to be focused on accessibility, which really gets into infrastructure. The other piece of it is going to be affordability, which really gets into the total cost of ownership. And then finally, the last one gets into awareness, which is the education and the outreach that we're doing to inform our customers and our communities about the technology and the benefits of the technology. One of the things that has driven us too, from our perspective as Exelon and Exelon's utilities, is we have strong support for transportation electrification across the different jurisdictions that we operate in. 2 of our states are actually ZEV states, Maryland and New Jersey. And then we also do have a number of EV or zero emission goals or initiatives that have been set or established in some of the states that we serve. Next slide, Cassie. What I've tried to do here is really try to simplify things. Designing rates can be really, really complicated, but I think at the end of the day, the basics are pretty simple. And this really, in my mind, does a great job of showing or explaining the benefits of EVs on the system. I think Paul did a great job, with the detailed analysis that he had shown earlier, but I'm going to oversimplify it here. Really, when you look at this, it's as simple as saying, what are the costs of your system operations? That's your revenue requirement. You essentially divide that by your load or your usage that exists on the system, and that gives you a resulting rate or $1 per kilowatt hour. As we get more EVs onto the system, that equals or results in higher loads. So the denominator increases in the equation, which ultimately does put downward pressure on rates for all customers. And the thing I would stress around all customers is EV drivers and non-EV drivers alike. I do think, and again, I think Paul mentioned this and Phil mentioned this in his remarks, it's really important for us to manage this incremental load or this higher load on our system. That is really going to be what drives that downward pressure on rates, or the magnitude of that downward pressure on rates. And there really are a couple of ways to focus on managing that load, and it's done through programs called managed charging. And those of you who are familiar with managed charging, there's really two forms of managed charging. One is passive managed charging, and the second is active managed charging. In terms of passive managed charging, rate design or rates is a perfect example of passive managed charging. It's something that exists, and the customer has the opportunity or the option to take advantage of that rate. In terms of active managed charging, that's something that the utility initiates or the utility puts forward on its own, again, to manage that load. And what you're really trying to do with that load is move that load to times on the system where there's excess capacity on the system. Next slide, Cassie. On this slide, I just want to talk a little bit about rate design principles. And a lot of what you see on here really does match up with Phil and his comments and those bond right principles. But there are a couple of things that I do want to highlight and leave you with. Is first and foremost, I would say that across all of our utilities, we have worked diligently and collaboratively with our customers, including the EVSE vendors, really to develop rate mechanisms that will encourage new charger deployment and reduce those barriers to adoption for electric vehicles. The three principles that you see on this slide, these are really principles that we developed as part of a broader working group process or working group sessions in Maryland as part of their PC44 program. And this was a specific working group that was designed to take a look at rates and rate design. Again, I'm not going to go through these in detail. First and foremost, our rate design principles, are really based on cost causation. I think Phil did a good job of explaining that before. Also, secondarily, having rates that are designed on historic embedded system cost. Historically, rates have been set for our customers, based on historical embedded system cost, and that basically does use each of the classes non-coincident peak. What that does at the end of the day, or should do at the end of the day, is avoid those interclass subsidies. And then finally, I think the last one is an important one, and Phil talked a little bit about this in his remarks, which is we do believe there are situations where you are going to employ explicit subsidies, and I know Phil doesn't like that word, so maybe I should call those transitional rates to achieve public policy goals. I think, though, what we would tell you is that, if you're going to provide those transitional rates or those subsidies, if you're going to employ those, it should be done where it is deemed appropriate, and it should be in support of state public policy goals. The other aspect of that is that those subsidies should be both traceable and reportable. In other words, it should be very transparent to everyone involved. And lastly, what I'd like to leave you with is on the concept of rate design principles. At the end of the day, rates should really be designed to recover costs for the utilities while optimizing the use of the grid and provide and deliver the benefits to all customers. Next slide. So in the interest of time, I'm just going to highlight a few of these. As you can see, these are our EV programs that we have in place at the various utilities in various jurisdictions across Exelon's utilities. The one thing I would want to point out on this slide is that, as you can see, we have infrastructure components of our program for residential and non-residential customers. We've got utility-owned programs, we've got rates and education and outreach, And as you can see, rates permeate across all of our utilities. So it is an important aspect of the programs that we have. Just to highlight a couple of these, I'll focus mainly on the commercial side here for the sake of the conversation, but willing to get into, any of the details on rate design that we have related to, residential customers. But in Maryland, we did offer a demand charge credit. That credit was basically equal to 50% of installed L2 and or DC charging capacity. Basically, the way it works is the customer receives a monthly credit for 50% of the installed capacity or the actual billed demand charges for that month if it is lower. This was part of or is part of our EV Smart program, which is a pilot program that we currently have underway. That demand charge was offered to all publicly available charging stations. The program did end on October 1st. Again, it was part of a pilot program that we had. The second example I would like to highlight here is in New Jersey. And in New Jersey, we do have a distribution demand charge credit. And basically what this is that any new and existing DC charging sites that have a combined service capacity of up to 750 kW are eligible for this volumetric rate. Charging stations or charging sites that exceed the 750 kilowatt threshold have to remain on our existing commercial tariff in New Jersey. The DC fast charging stations that are eligible to receive this volumetric rate the rate for that program is 10.9 cents per kilowatt hour. And again, this is distribution service only. It doesn't include the commodity piece of the bill. That program is in place through December 31st of 2024, or when a new rate is based on when a new rate would be developed based on a cost of service study that's prepared by ACE and then approved by the BPU. I think that addresses one of the questions I saw in the chat earlier as Phil was talking is, how do you go from these rates being transitional to permanent? How can you take something away? I think the important thing is what we've done here in New Jersey is, again, provided transitional relief for the EVSC companies and public charging. But what we've done here too is that we can collect the data, we can do a specific cost of service study that will give us a more accurate or a better rate that's associated with true cost causation as it relates to this specific customer class. The other thing I want to mention too, as one of the things that we've held consistent across all of our utilities is that we have essentially, if you're taking a rebate or an incentive or participating in our programs, we are requiring that those entities, whether they're residential or commercial customers, actually provide us with charging data. Why that's important? One, it allows us to understand when folks are charging, how they're charging on our system. What that also does is it allows us to collect the data. It allows us to do these more in-depth cost of service studies and then allocate these costs appropriately amongst the different rate classes. Thanks, Cassie. I'll turn it back to you now.
All right. Thank you so much to Chris and Phil and to Paul. And so now we'll be transitioning to the discussion portion of our session. Invite the panelists and the participants to come on back on camera. And I would like to again start with inviting some comments from EVgo and Greenlots. I know we had some great information on different options for rates, but would love to hear from the companies about what you've been seeing, if there are best practices that are emerging, and what is helpful to incentivize investment from the private sector.
Yeah, I can chime in with a few thoughts here just to kick it off. I think if there's one thing that's been clear, there hasn't been a one size fits all. Many utilities have taken on different approaches depending on the sort of elements that works best in their service territory. There is one thing that I think kind of caught my attention and I really enjoyed Phil's presentation in particular. There's one thing that I think was also interesting is that many utilities kind of took on this short-term, long-term approach. And I think sometimes it has been helpful to test out some pilots, test out some ideas, and then develop a long-term solution. I know that's been the case in Maryland. Other utilities have kind of taken a different approach. But I think what's been really interesting is that low load factor rates, or rates that are applicable to low load factor customers, aren't necessarily something new. They've been in place in some places, whether it is for agricultural customers or other types of spiky load customers with spiky load. So I think that it's been kind of interesting to see in some utility service territories leveraging those rates, those existing rates, and doing something that is applicable to low load factor customers in general. And that happens to also be beneficial to commercial EV customer accounts. Dominion in particular and Madison Gas and Electric have kind of taken on this approach of like, we recognize that this is a low load factor rate, and anything that kind of matches those criteria, independent of whether you're a commercial EV or a regular customer. And I think this is kind of something worth exploring a little bit more, and certainly very interesting. I know that there's been a comment in the chat about embedded cost versus marginal cost, and I would be really interested in hearing what some of the panelists have to say about that, given that EVs are a new load. And as Paul mentioned earlier on, there's certainly significant benefits to that. So yeah, this is my sort of quick comment on this right now, and look forward to talking more.
Thank you. And Tom, if you go right ahead.
Sure, thanks. Yeah, I mean, there's so much to talk about in so little time. But I just want to thank the panelists. I think that, and thank you, Cassie, for kind of creating that juxtaposition. You know, Greenlots is steeped in a lot of this stuff, though admittedly not all of the wonkiness that Phil was alluding to. But we'll acknowledge that, you know, if we're thinking big picture, there is an incredible opportunity for ratepayers all over the place, and indeed for economic development and so many amazing things. But we do have a lot of work to do to put the pieces together to get there. And so I think that was reinforced, you know, by this panel as well. I do want to acknowledge, I really appreciated the way that Chris talked about sort of passive and active load management. I think that's really helpful for folks to think about. I will acknowledge that in addition to, you know, I would just say maybe not a different perspective, but Greenlots definitely feels that both rates and technology can both be utilized for both active and passive management. So I do want to acknowledge there's a whole lot of different ways of doing these things. And I don't want to present that as complex. Some of it can be, but you know, there are utilities, technology providers who can make it really simple. And I do want to acknowledge the importance of making it really simple for drivers and customers. So there's all kinds of algorithms and things that can be happening behind the scenes. And then it can just be a, you know, yes, no question for a driver. So there are a lot of ways that we can make this very simple, and would just acknowledge that Greenlots sort of philosophically has historically taken a position where we really focus on leveraging ratepayer investment for infrastructure, you know, physical stuff. We haven't taken the approach of sort of thinking about whatever language you want to utilize, but leveraging ratepayer investment, if you will, for rates. And I just acknowledge that that's something we're thinking a little bit more about as more of our customers are asking us questions about rates and sharing different perspectives about their appetite for leveraging technology. So we'll just acknowledge that I think this is a really important conversation. I think there are a lot of different ways to approach it. But I really appreciate what the panelists have shared, and also, of course, what Corinne shared. I mean, this is a big topic for the industry, and there are just a lot of different ways to go after it.
Thank you, Tom. And I think a great point that a lot of this conversation is in the weeds for the policy wonks, both on the panel and listening in, but making it simple for the customer is extremely important. Jasmine, would love to turn to you too, to just share a little bit of information from the perspective of NARUC. We know that you've been working with the commissions across the country on this and other issues, and would like to hear a little bit about what trends you are seeing.
Of course. Yeah, well, thank you so much for having me today. But I did want to start off with just a couple of points that are really pulled from a recent, not too recent actually anymore, but a 2019 study that we did on key trends and issues for state regulators. And really what we came to the conclusion in this paper was that the considerations for EV rate design, which can help mitigate and avoid the negative grid impact, as well as equitably allocate costs, are based a lot of times on two principles. And the first is that rate design should be utilized to increase the efficient usage of existing assets rather than undergoing expensive distribution system upgrades to serve EVs. And this is a point that Paul just brought up as well, and I think it's a really important point to keep in mind. And the second one is that bill increases due to EV infrastructure upgrade should be kept to a minimum for consumers who do not own EVs. And so really honing on that. How do we have this benefit customers who may not have EVs, but keeping this equitable as well? And so the commission approaches are really laid out in kind of three different areas that we focus on in this report. And the first is on time of use rates. The second is on real-time pricing. And the third is managed charging. So this idea of this active charging, managing and charging. And so one of the things that I do want to bring up that I think is interesting that has really come out of this conversation is this interaction between consumers and utilities and this education and outreach component. And this was also brought up in the introduction today. And I think that in thinking about how consumers are going to be able to realize the benefits, I think it's also important to realize that it's not always easy, perhaps, for some consumers to understand how to use the applications or the various tools that they have available. But also, it's not always perhaps feasible for all people to participate in these programs if they are low, medium income families. Perhaps they have different working schedules and such. So I think keeping those in mind is important as well. And also when we think about managed charging, there are additional costs that the consumer or perhaps the utility would have to incur in order to make this happen. So I think keeping those in mind, and I will drop a link to the report that we did, which goes a little bit more in depth into some of these considerations, but I also want to give Nick a chance to comment a little bit more specifically on these issues as well, but happy to answer any other questions later on.
Thank you. And Nick?
So there are a number of things that I could cover, but I think the one that I really want to cover the most is the problem with relying on utilities to do this through ratepayer funding with like incentives or something like that. And I'll give you an example of why I think it's problematic. We have a study that one of our universities and the environmental department of the state did that shows where DCFC chargers should be in order to basically reduce that initial barrier, the range anxiety barrier. A lot of those are in the UP, like per ratepayer, way more than you might expect, because there's a lot of area, not a lot of people in it. So you need to have chargers in a lot of different places up there. Now, we also have some of the highest rates in the nation in the UP. So relying on the utilities to basically incentivize the installation of the chargers, which then gets put on the ratepayers' back, is difficult for a situation like that because the folks that are actually paying the rates aren't receiving most of the benefit for it. So if you're using anything other than the benefit from rates, it becomes difficult to justify it on a ratepayer basis in a place like that, where you have already very high rates, and most of the benefit is going someplace else. So it seems like if there were a way to do it at the state level or even the federal level, not just utility by utility, it might be a lot more efficient and match the incentives to the benefits a lot more.
Thank you, Nick. Are there comments from the panelists? All right, well, one thing I did want to turn to were just some of the other states on the line to hear a little bit about what rates or issues around the issue of the demand charges in particular you're seeing in your states. And Chris and Ben, I know that both of you are working both in the EV and the rates kind of nexus, so would welcome thoughts from Hawaii and South Carolina.
I guess just a couple of questions that I'd really throw it out to everyone to opine on is one, in particular, the use of just coincident without non-coincident demand charges. Just in terms of, as that a solution, does that work for providers and the utilities in terms of dealing with that cost recovery from peak demands? But then taking it a bit farther, just curious as to how much it's been explored around dynamic rates. And what was the experience of utilities that have tried with dynamic rates to essentially avoid the use of demand charges altogether and substitute it instead with some sort of event-based capacity recovery for the grid? I know that gets even more complicated. So it is always that balance of how do we deal with the complications for the customers, but with some of the larger fleet customers, deal with it, they may be able to have the sophistication to respond to a dynamic signal. And then also, going on again, dynamic on the system level versus dynamic on the circuit level. And so I'd be curious to see what the utilities have looked at in analyzing demand peaks on the individual circuits, as opposed to just looking at on the individual or on the system as a whole. So that's a few questions out there, but just thoughts in the head in terms of what are the, broad range of tools or the experiences, because I know a lot of people have dealt and looked at these types of things, but what has, the utilities think about that and versus, like the EV Go and the green lots, what's your experience in trying to manage solutions against just peak demand charges or dynamic rates?
Well, Cassie, I could start on that one. I'll defer to Chris and maybe Paul on specific utilities and the use of coincident and non-coincident peak. So in our paper, we did not land on any final solution between coincident peak and non-coincident peak. One is for the system, as you know, and one is for more of a granular look at the feeder, go from that substation going to the host site or the customer. This is going to become more of an issue with medium heavy duty fleet electrification, as you probably know. But that's why I talked about line extension policies too, that are also going to be important in allocating those distribution upgrade costs, not rates, but distribution upgrade costs. So each commission deals with the peak methodology differently. That's one of the reasons we didn't land on one or the other. But I think generally speaking, members of ATE favor a long-run marginal cost approach based on cost of service studies over the longer term, recognizing these assets are going to be in the grid 10, 20, 30 years. We really think transportation electrification is a transformational technology, just like air conditioning was in the 60s and 70s. These assets are going to be around for a long time. So embedded costs are important, but short-run marginal costs are also important, as I put in the chat, because some commissions, like California, require short-run marginal cost allocation when we have a new technology coming in the system. So you ask a really challenging question. I think it kind of varies state by state, but really, really important stuff. I'll let Chris speak for his views on embedded. He made the point on embedded costs as well. Chris?
Yeah, I would tell you, Chris, maybe to your question directly, I've got the answer for you. It depends. Look, we're a multi-jurisdictional holding company. All our systems across Exelon are different. The way these chargers are being utilized are different. It really depends on, are you dealing with primarily an urban population versus a suburban population? what's the penetration rates of home charging, how much of this charging is going to be used for, publicly available charging that's being used for whether that's to top off or as your primary source of charging. So it really depends at the end of the day. And I think what I would try and reiterate or say for us as Exelon, I think we've been open to having the dialogue and the discussion with all the key stakeholders in this. And as you can look, in Maryland, we had a very robust stakeholder process that determined what the programs were going to look like. And that's the rate design that we landed on in Maryland, which is a straight demand charge credit. I think if you look at New Jersey, again, I think this is something that was a stakeholder process. It was a negotiated settlement. The EVSC companies were at the table, and we wound up with the KWH, demand charge reduction. And we've put in a stipulation, to take a look at this at some point, either at the end of 24 or before 24, using cost of study data to really come up with what we believe to be the best long-term rate or the most appropriate rate at that point in time. So again, Chris, I think the short answer is it depends.
And go ahead, Phil.
Yeah, just excuse me for a minute, Tom. In Illinois, Chris, there is real-time pricing in Illinois as well. And ComEd, one of the Exelon Utilities, whenever I go to Illinois and talk to certain people in Illinois, some people really like that real-time pricing, RTP, that ComEd offers, and they benefit from that. It really brings the commodity price down. But some people don't like it. I know people in some utilities in California think RTP, real-time pricing, dynamic pricing, is too complicated for the consumers, and it just confuses consumers because California rates are difficult enough to understand with tiered pricing, TOU, and then you throw an RTP on top of it. So like Chris says, it all depends on the jurisdiction. Sorry, Tom, I interrupted.
I just wanted to respond, to Chris Junker's question. So a couple notes. I mean, one, as a driver, I would acknowledge that I understand EVgo is starting to provide time of use pricing, and I think that's important to acknowledge because Greenlot's business model is not one where we own charging stations. Our customers own charging stations. So we take the philosophy of providing tools for our customers to manage their own charging. And yes, we can provide advice on how to do that. And so I think it's exciting to see more asset owners providing those price signals to drivers. You're probably familiar, but Hawaiian Electric, I think, has a pretty good history of providing some of those signals or visibility to drivers for public DC fast charging. But I will acknowledge that not all customers leverage these tools for different use cases. For instance, if you're a customer and you want to take the approach of never seeing demand charges with Greenlot software, you can do that. But there are some user repercussions associated with that. So just want to acknowledge that I wouldn't say there's an easy button for any of this stuff, unfortunately, despite the importance of providing an easy button, if you will, in terms of choices and signals to drivers. But I think there's a significant opportunity for whoever is providing charging infrastructure to be able to use the tools that exist already in a way that can better protect folks from unexpected costs, as well as provide more visibility to users of costs associated with their charging activity.
I can throw 2 cents in. I think it will be a hoot to go back and listen to this 10 years from now and see how much of it we got right and how much of it we got wrong. But I want to make one kind of, I suppose, to state the blazingly obvious, scale will change so much of this. And that's one of the reasons I say it'll be interesting to think back on this when we get closer to scale. And then that kind of leads me to think about the possibility of new sort of injection of funding for these services and infrastructure projects. I think this group who are together today are going to have an important role to play, and indeed our friends at DOE sort of opened the door to this, assuming that we do get an infrastructure package. And there's going to need to be advice given to the agencies at the federal level and at the state level, because states are going to have to match funds for a lot of these federal grants to make sure that we use this money very wisely and strategically now to try to overcome some of the predictable or foreseeable near-term gaps so that we can get to scale faster. Because I was citing policy cases based on a memorandum of understanding that 8 states struck almost 8 years ago. It seemed very ambitious at the time, and let me tell you, none of those states are anywhere close to achieving it today, possible exception of California. So we have to be working in a spirit of experimentation, but also in a spirit of sort of a carpe diem. We have got to seize the opportunity, among other things, I would say, to try to lessen the tensions that revolve around some of these very important and sometimes seemingly zero-sum decisions around rate design. I guess this is a plea to say, if we get an opportunity to throw some money at this, let's not waste the opportunity. Let's make sure that we use that money wisely, so that we can get on to the more exciting stuff of like thinking through how to make this really, really seamless for the drivers and for the fleet operators, because that's what's going to make the difference here. Sorry, my soapbox. I'll get off it now and go back to my spreadsheets.
Thank you, Paul, and well said. And Babatunde, you have a question?
Yes, I have a comment and a question. I think a lot of interesting things have been said today. Since EV charging is dominated basically by residential late night charging, Tom made a very interesting point where he says, sending the right price signals will be critical to ensuring that people charge during off-peak periods. My question would be that if you have a wide-scale adoption of EVs, like in the case of Paul's scenario where he says 80% of EVs are 80% of vehicles are EVs, how does that affect peak demand? Does it shift peak demand at all? And maybe Phil can help me with this.
I mean, I would say my reaction is, if it's done properly with the use of the right technology, it can be what you want it to be, right? Because, if I'm an EV owner, if I plug my EV in, I can set it to charge from 1 to 3 a.m., right? Or I can set it to charge from 3 to 5 a.m. That's a choice that I make. That's what I do because I take advantage of the EV only time of use rate in my service territory. Again, that's one form of us doing that. There are mechanisms, and again, to Tom's point, there's technology that exists that the utility could influence that. Or again, we make it so easy and understandable for a customer to say, you know what, I don't need to charge at 8 o'clock at night. I can wait until 1 in the morning or 3 in the morning because I only need 20 miles of range. And those 2 hours or 3 hours before I leave in the morning are plenty for me to get to where I need to be. So again, I think that it goes back to a point, I made before too. having the data is important for us to really understand, again, how many people are charging at home and what are you using your at-home charging for, right? Are you only, and I think that some of the studies that I've seen, I think the median length of charging at home is only 2 to 3 hours, right? So we could really kind of build, 4 or 5 blocks of 2 to 3 hour charging times overnight for a lot of EV drivers, again, that spreads that peak out over a longer period of time, or avoids creating a peak at times that you don't want to create that peak.
Thank you. That's a very good response.
Thank you. And I believe that Ben had flagged a question, and then Chris. Ben?
Yeah, appreciate that, and certainly appreciate the presentation. So one of the questions that's gone around for me, and certainly for our agency, is, we know that there can be benefits from the downward pressure of EV penetration, right? One of the questions is, how do we verify those benefits or that downward pressure? So are states or even FERC possibly developing, standards or procedures for auditing or just investigating where those benefits to the ratepayers are going, or how we can verify that those are actually being attributed to the system?
Well, one comment I would make, Ben, and I'm not the BCA expert, but I think to some degree it depends on the benefit cost test that you run. And you really need to run a test that looks at ratepayer impacts, because not all benefit cost tests look at ratepayer impacts. There are some things that are underway in some of our jurisdictions as it relates to benefit cost. We're going through I wouldn't call it a proceeding. We're going through a working group discussion right now in Maryland to develop a BCA methodology for EVs that will be delivered to the commission, a report on December 1st. So that will give you that's kind of one of the things that we're focused on in Maryland right now around benefit cost. There's also the National Standards Practice Manual that was updated, I believe it was last year, really to reflect, I think, the National Standards Practice Manual kind of made its name for energy efficiency. It's been updated and expanded to look at all DER technology, including EVs. I will say there are some aspects of the NSPM that we agree with and make sense. There's also aspects of NSPM that we're not completely on board with, and we don't think it is fully reflective of the benefits that can accrue from the technology.
So I guess what I would add to that, all really well said, Chris, as usual, that as Marianne knows from New York, we looked at we looked at 3 different possible tests: so ratepayer impact, total societal, and total resource cost. And I know that regulators, and Phil, you can kick me under the table here, but yes, this complicates people's lives, but looking at sort of a multiplicity of analyses so that you understand it from different angles probably makes a lot of sense. And it's our view, from having done a few of these now, that the great good news about this technology is that it seems to succeed in delivering meaningful benefits under almost any test you put to it. Maybe that's not always going to be the case, but and I should also hasten to add one other thing, because I think this is really important, that as the electrical grid gets cleaner, and it still needs to do that, but there are heavy pressures on it to do so and incentives to do so, that then translates to very meaningful societal benefits on the clean air and climate side from doing this. And those need to be valued, I think. And some of that, look, candidly, that happens at a regional and nationwide, if not a global level. But that's the world we're living in now, and we have to design our tests and our analyses to meet that. But I think that you'll find, Ben, that there's ample evidence that indeed you you will be seeing the benefits. You also would not want FERC auditing, and I don't think that they're constitutionally or legally able to do that. That's probably also good news.
Yeah, Ben, just maybe a bonus perspective, if I may, from Greenlots. I just want to acknowledge that when we're talking about specifically ratepayer benefits associated with rates, there is a scale question. And I think it's important for all of us to recognize that. And I think a number of commissions around the country are, on the one hand, recognizing that and therefore thinking about the ratepayer cost benefit analysis in different ways. But I think other jurisdictions are struggling with that because the existing ratepayer cost benefit analysis or test doesn't necessarily, it doesn't account for the scale that we need to get to in some of these cases. But what you also heard from Paul is a scenario where some of the benefits that ratepayers are seeing are not going to be in rates. They're going to be in lower fuel costs for their vehicle that they've just switched to a different fuel. So I think the more that the collective we can be both cognizant of the importance of scale for that downward pressure on actual rates, but also the value of other benefits and thinking about how we can incorporate those in a more holistic analysis. I think if we have those two pieces, we're all going to be very successful in moving the market forward and ensuring, indeed, ratepayer benefit.
Thank you. And I did just want to offer it to Marianne. I saw that you went off mute. Was wondering if you had a question for the group.
No, I was just going to make a comment after Paul had indicated that we were aware of the ratepayer and societal benefits. I think that MJ Bradley did do a very thorough study on benefits from multiple perspectives. I was just wondering if other utilities are struggling with kind of quantifying the revenues achieved through charging rates when we're going through such a transition period and we just have the unknown at this point as to what rates are going to be maybe a couple years down the road or 5 to 10 years down the road.
Well, we do just a couple of things, Marianne. So we have, first of all, I need to put in a plug for the EPRI total value test. So EPRI has tried to go beyond a societal cost test, as Paul talked about. Total resource cost test really doesn't work for TE in my view, because the ownership of a car and fuel savings is not under the control of the utility. So you need things under, this is a much broader cost test that we have to, and of course, the displaced fuel savings that Paul mentioned as the consumer benefit have to show up on that cost benefit test. So EPRI has developed the TVT, we call it. So you all may want to take a look at that. Second thing, decoupling, we may have to look at decoupling again. So if you talk about revenues coming in, right? Many utilities are decoupled. So if you have revenue per customer decoupling and you have a 10% increase in revenue, let's say you can attribute it to EV charging, guess where that goes? That just goes automatically back to the customers, the residential class. Now, is that the smart thing to do when we want to get charging infrastructure out to BIPOC and disadvantaged communities? We want to do rural, we want to do this, that, V2G. I don't necessarily think so. And then we have rate riders. We have rate riders for storm cost recovery, grid modernization. We have all sorts of things. So this total revenue requirements, how much revenue is going to come in from charging is going to show up in a rate case, a general rate case, but it's going to be a little bit difficult to separate out all the different loads. We're probably going to have to get more creative and hire some consultants and just figure this out a little bit better. AMI can help. If a utility has AMI, you can do load disaggregation and try to figure out how much is due to the refrigerator, the water heater, EV charging. So there are ways that we can get at this stuff, but the point I'm making is to prove downward pressure on rates with revenue decoupling, rate riders, and the GRC process, it's going to be complicated. it's going to be challenging.
Thank you, Phil. And Chris, I know that we are at the top of the hour, but I'm wondering if you have a question or a final word for the group.
Just the final point, and everybody kind of touched on what the question I was going to have. But when we talk about benefits and how it accrues to everybody and kind of the larger societal perspective, just touching on what the gentleman from DTE said earlier, having that long-term perspective and running scenarios will be important in understanding what are we incentivizing. I mean, we always want to make sure that we're putting in place something that will create a benefit today. But it's also important to think about what are we doing right now and how will it play in the future. Many of the states here, I'm sure, are having massive transitions of their generation and planning, and where you think and when you want people to charge could change dramatically based on the mix of generation resources, be it renewable, could be solar, geothermal. And so once again, it'll depend on where you are and how your composition of both the vehicles and how people get around, but then also what your generation system is going to look, because we're going to condition people today in how they charge their vehicles. And so if we condition them in a way that suits today, but that's counter from where we want to go in the future, that's something that we should just have an eye on. It's not going to be, no one can predict the future, but it's something to think about.
Hey, Cassie, if I could make one comment, I know we're pressing up against time here, but for 30 seconds quick, I think Chris makes a great point. I think as you design these programs, and we've tried to do this, is build in flexibility. Don't lock yourself into, something long term. And again, I think it harkens back to, my beating on the data piece, right? The more data we have, the better we can understand this. We can better understand what we're trying to incentivize and are those incentives working? And it allows us to make modifications to those programs rather than locking ourselves in long term.
Excellent. Well, and on that note, I would like to thank all of our panelists and the folks who participated in the discussion. Clearly, we could have gone a lot longer than the few hours that we had, but it was a good start. And so a couple of quick announcements before we conclude the event. As mentioned, we will be hosting another workshop on November 16th from 1 to 4 p.m. to explore medium and heavy duty electrification. We'll be sending out an agenda and a registration link to those who are interested in joining. And again, we'll be taking the comments and the questions from the chat and takeaways from this discussion, as well as some subsequent conversations we'll be having with states to inform the development of an online resource that states can use as they begin their EV planning and investment strategies. And so more to come on all of that. But again, a big thank you to our speakers today, the folks who participated in the dialogue. This was a bit of an experiment in terms of the format, and we will plan on coming back to it in our next event. And a thanks to all of you for attending. If you have any questions, please let me know. And please also keep an eye out for an exit questionnaire that should be arriving in your inbox. Thanks to all and have a good day.
Thank you.